In the middle of like solving these wild expressions, and surprisingly, Cade had a good point of like, how would I approach this first? Like procedurally, what would I do? I would first look at these guys here and see, is there any log rules that need to be applied in this case? Girls, can you just, will I record this guy here for the people that aren't here? I would do my log rules first, okay? If we walk through this guy, there's no exponent on this guy. That square root annoys me, right? So I'll have to deal with this guy here. This guy doesn't have an exponent, but that one does, okay? So all I would do is rewrite this as he's fine, log times log 4, 2, just to identify that this is a separate block that I'm going to solve on its own, right? And then this is the weird one where square root of something, it's just another exponent law that we're going to have to know, right? If you go back to this sheet here, where is it? It's one of these guys here with fraction exponent. So, and it goes both ways, right? If I have something written like this guy here, I can essentially like write it as a fraction. I know that you see that like this is a to the power m. I might even put like another example next to this in terms of the idea of, instead of just writing like that, where this is like the full rule and everything that's happening, where you would encounter it are these examples. And this is the easiest one that we would be encountering, right? We have this guy right now where it says square root of 8, right? I could essentially just write that as 8 to the power 1 over 2. Reason being is now I can use my power law to bring him in front of this like log form piece. Yeah.
It would always be 1 over 2.
Well, so then there's a good question. I was going to do this guy here. So what if it was one of those weird ones where it said, and usually it will just be in these guys, but if it said 3 of 16, right? So then I would write it as 8 1/3. Reason being is now I can put him in front.
What if it doesn't have an exponent? You take 1 over 2.
Yeah.
Okay.
Yeah. So again, this is showing like the whole nonsense of if you have a fraction, you can put the exponent on the guy under the hat, and then it's a whole other. But this is more where you're going to encounter this guy. So that's why all of a sudden this guy becomes 1 over 2 times log 2 8. Why is that easier? It's because now I can easily figure out 2 to the power what is going to give me 8, right? Go through the rest of them. Log 2 is in the front. There's no exponent on the 16. I know this is going to be a weird exponent because I've got a base that is less than 1, and I've got like an output of like, greater than 1, 16 or something like that. So this one here, however, base, I've got my, let's call it output, and then the exponent on that. Let's drag him in front. 2 times log 2 to the power, or output of 4. The idea now is we will solve these individual pieces right here. So if this is step 1, step 2 is just go ahead and solve logs. Right?
Where did 2 come from?
So that exponent?
No, but like just like plus 2 there.
Oh, so when I'm bringing this guy in front, essentially all I'm saying is this turns into this.
So do you even need to do that? Or can you just solve the fraction in front and then say 2 to the power what equals?
Like 2, so you said 2 to the power what would give you 16? It ends up,
Yeah.
yes, it would, because, yeah, it still would fly, right? 2 to the power what would give you 16? This is just one way. If you prefer to say 4 squared and then go 2 to the power what would give me that value, that works as well.
Because that's what I did. I didn't even use my weird button there. I did it all.
Cool. Yeah, if you want to, like,
It's so good.
I like that. The only reason why I would show it in this case is just that procedurally, especially if you have like square roots and stuff, you do the same thing every time. I'm taking the exponent and I'm putting it in front and then multiplying it by, and you're dealing with smaller numbers. it'd be easier for me, and this one was easy because it was 2 to the power of 16. 2 to the power of what would give me 16. But 2 to the power of what would give me 4? Like, that's stupid simple. So in this case here, when we run through it,
For the exponents.
2 times log 2 4 is just 2 times 2, right? 4. Whereas the different way you did it was 2 to the power of what gave me 16?
Yeah.
4. When you get bigger numbers as an output or bigger numbers as an exponent on there, then it would just make it harder, like mental mathing that number. But it still works as a thing, and if you prefer it, go ahead.
And for the square root, I did that too.
Perfect. So then you knew 2 to the power of what would give you the square root of 8?
Well, no, I just did square root of 8, and then it was 2.828, and then I just did it until I found a number.
Oh, okay. But again, would it not have been easier to just go 2 to the power? Like, I know most of my exponents of like 2, and just like 2 to the power of what gives me 8 versus 2 to the power of what gives me square root of 8, which would be a little more challenging. I'm not saying your way doesn't work. I'm just saying in terms of when we get with, these are baby step ones, practice ones. When we get to bigger values, I would suggest just kicking that exponent into the front, so then you're dealing with smaller values.
Okay.
But your choice. Log 4 2. That's the only weird one we were talking about at the back, right? So log 4. What is the exponent that would make it go smaller? We were talking about negative exponents making fractions, but 4 to the power of 1 over 2, right, is going to give me my output of 2. So now we basically have solved all of them right here. So the last step on these guys here is just like combine, right? Execute it out. So we're going to have 1.5 plus 1.5 plus 4. So 6, 4, 10 is roughly what it should be. Unless was there any subtractions in there? Was there any negative exponent? No, okay. So roughly that's where we're at with those guys there. So was there anything? Did I miss one on there? I feel like I missed one.
Yeah,
Which one did I miss?
-4.
There it is. The middle. I didn't do this guy right here. I was like, there's something missing in that. So let's just. I did this guy. I skipped over that one for some reason. I wrote it. So.
Because I keep sneezing, it's not good.
Oh yeah, because that one I didn't need to do anything to, but we'll say log 1 over 4, 16, and then plus 2 log 2, 4. So this one would end up becoming your, what was the exponent on this guy here? 1/4 to 16. What exponent would I need to take 1/4 to get me 16? -2, perfect. And then this guy here, when we put it in front, 2 times 2, so plus -4, and then plus 4, right? So then in terms of that, I'm just going to end up with 3 plus -4 plus 4, end up with just a value of 3. So apologies for skipping through that there. That stinks, but the rules still apply. And then, Jeremy, this is the procedure I would walk through. Apply the log rules first to ensure that you're using simpler numbers, then solve the logs that have been like simplified, and then we just take all the numbers and combine them together. But so again, on this guy here, what I will do is strictly just identify what properties. So step 1, what properties or laws or rules, I should say, I want to do first. So what I mean by that is this guy right here. I'll be putting that guy in there, power rule, right? Combining those things together in this case. So we could then rewrite it out as 2 times log 1/3 27 minus 3 times log 2 1 over 8 plus 16 times log 27, 1, and then subtract 3/4 times log 1/2 is my base, 16. So, in terms of working through this guy here, when asking myself 1/3, what to the power of 1/3 would give me 27? So we can, right, just write out that that's not going to change. 2 is going to be multiplied by what I solve with. So essentially, if you want, you can, right, like just say these parts will all be done individually. And to be even more specific, this is what gets tackled next. We're solving each of those log forms. So we can now ask ourselves, right, in this case, 1/3 to the power of what would give me 27? Like if you have to go 1/3 to the power of what gives me 27, feel free to go ahead and do so, right? But my hope is in looking at this, you look at 1/3, realize we're starting with a base that is a fraction, and let's see what's the relationship between 3 and 27. Well, that relationship is going to be 3 to the power 3. But because we're starting with a base of 1/3, this is just going to be -3. And that's ensuring that using the negative exponent that I'm taking the fraction, essentially flipping it, and then going to the power of. From there, 3 multiplied by 2 to the power of what would give me 1/8. Now again, I'm starting with a base of 2, but ending up with a fraction. So I'm thinking there's going to be a negative exponent in there somewhere, but what's my relationship between 2 and 8? Will be to the power of 3. So this will also be, right, -3. Those are meant to be brackets there. Put those like this. And now, 27 to the power of what would give me 1? Well, that one's just going to be 0. So this is just going to disappear because 0 times anything is just going to get rid of it. And then last but not least here, we've got 3/4 times log 1/2, 16. So the 3/4 we leave. The 1/2, the base is a fraction. Output needs to be 16. 2 to the power of what would give me 16? So I can look at that and say 4. But because I'm starting with a fraction and ending up with a whole number, I'm going to make this times -4. So in all of this here, when we run through it, we're going to end up with -6 to start out. Subtracting a -9. Adding 0. And then subtracting, in this case, a -3. So going through all these guys here, we're basically taking -6, subtract a -9. So essentially we're going to end up with +3. +3, subtract a -3, which is going to leave me with 6. So then that's all I'm going to end up with there. Just to reiterate and go back through it again, I had mentioned before, I didn't come back to it, but the first thing we did was properties. So that was like this step right here, right? We executed everything. Every exponent that was on those logs got put in front. And then my second step right here that existed was just solving. Solve logs, right? 2 to the power of what gave me 1/8, 27 to the power of what gave me 1. And then step 3 would basically just combine, like multiply, combine, execute, right? Just do your operations and then add it together. But procedurally, let's try and set things up first, then go to solving each individual piece and then multiplying through it. But that would be my suggestion for this guy here. The next thing we'll get into will be further reducing these guys based on these laws and rules. So this sheet here is going to be ready for you. We'll start with this guy next time.